All right, as promised, here's lessons 20 and 21. I just recorded 18 and 19 right before this. So yeah. Lesson 20 covers the last part of internal forces, right? So I just wanted to briefly cover a couple things that I think I've already said before, because I made these presentations back to back, so I already kind of had this in mind to talk about beforehand. But before you cut the member, right, these are going to be your three unknowns, right? You can only have three unknowns because it's an equilibrium problem that's non-concurrent, which means you only have these three equations at your disposal. So you can only have these three unknowns to be solved using this equation, right? So you have to have solved for all of the unknown external forces first, because say you're cutting at A, right? And if I had an unknown here, I would have that same unknown plus these three at this cut, which means I can't solve it. So that's the only big thing to remember, is that you have to solve for the external forces first. And then only once they're found can you cut the member through the specified point on the problem. So that was the one thing that I wanted to bring up. The second thing is distributed loads, right? So if you had this distributed load across the whole body, right? Say I already solved for my external forces, and then I had to cut at A. That chunk to the left and to the right still has a distributed load on it, right? Which means I can't approximate this to be one force, because that force is going to fall right here somewhere. So if I consolidated this distributed load before I cut the member, I would have one force right here, but that's not exactly accurate, because then I would have nothing on the left side of that cut, which is not the case. So in the case of a distributed load, you're going to need to consolidate it twice, right? You're going to need to consolidate it one time before you cut to solve for the external reaction forces, right? Because you need this to be one force to solve for any reaction forces at the two ends. But then when you get those and you're going to cut it, you have to reconsider it as a distributed load, so that when you cut it, you still have these two chunks with distributed loads on them, right? So then if, say, you're looking at the left side, you can consolidate this to be one arrow somewhere around here. Or if you're looking at the right side, you can consolidate it to one arrow about here. And that being said, since this is a rectangle with a triangle on top of it, you really don't need to consolidate it to one arrow. You can have one arrow for the rectangular part, one arrow for the triangular part, doesn't matter. But what I'm saying is you can't consolidate it in terms of when you're looking at the shear normal and moment until after you have cut it, so that you still consider the chunk that's on that half. Other than that, everything's the same. Again, remember to use, in terms of your answer format, the magnitude and units, direction, and which body it's on, because if you don't specify which body it's on, we don't know if you were looking at an upward shear force here or an upward shear force here, because they'll be opposite of each other. But that's it for internal forces. Fairly simple. It's just a matter of a 2D equilibrium problem after you cut it. The new thing this time was cables, right? And cables are pretty simple once you understand conceptually why they're solved the way they're solved, right? So cables, think of it as a rope. If you're going on a rope swing, right? I don't know if anyone's done that before, but that's usually my go-to example because I love rope swings. So if you're going on the rope swing, your body weight is pulling on the rope naturally, right? At no point will you ever be using a rope and then pushing on it. So that logically won't do you anything because it's limp before you apply a tensile force. So that being said, when we're using cables or ropes or whatever they happen to be in our problem, any force that is on that cable is going to be a tensile force, and it acts in the same direction as the cable. So each cable will only have one force building off of it, right? You can approximate it into its components, but you don't need to because it's in the direction of the cable. So in terms of solving for the tensions in cables, there's two main ways to do it, right? So you're going to have a large system of cables, and you'll either be asked to solve for all the tensions in all the cables, or you'll be asked to solve for one specific tension and then a couple other things off of it. But generally, cable problems have a few components to them because of how um, I don't want to say simple they are, but in terms of how straightforward the calculations are, right? So in the case that you're asked to solve for all the tensions in all the cables, right? It's easiest to hop from joint to joint. Kind of like when we did trusses method of joints, you're going to do the same thing with cables. So if I had a bunch of cables connected to each other and then there was something hanging down off of it, right? In the problem, you'll know the thing that's hanging off of it. And then these two cables that meet at this location where that thing is hanging will be your unknowns, right? So because that is a concurrent system meeting at this point, you only have your two equations. But that's okay because you only have your two unknowns, because your unknowns are the tensions in this cable and the tension in this cable. So you can solve for that using the forces in the x direction and the forces in the y direction. So this is essentially just a particle equilibrium problem. That being said, if the question asks you for a specific tension in like a particular section of the cable, so I just kind of was drawing this thing, and or this like series of cables with like a load here and a load here and then a mount here. And I'm assuming the problem was asking for the tension in this cable, assuming that it like continued up. But so assuming that the question only cared about the tension in this cable, what I can do is I can just say, all right, I'm going to cut it here, because I don't care what the tension in this cable or this cable is. I only want the one here. So that's the benefit of that, because this load will be known and this load will be, so usually loads are given, right, as something hanging down off the cable. Your reactions you can find looking at the external forces, and then once you cut it here, you expose this tension, and that's the only unknown, right? So you have, in this case, a non-concurrent system, because you have these loads going through these points that are not one point, right? So that non-concurrent system allows you to have three equations, which allows you to have three unknowns. So between these three equations, you can easily solve for that tensile force here. So the idea behind cables is that you really want to familiarize yourself with understanding what the question is asking and how that immediately translates to how you want to solve it. And you also want to familiarize yourself with the different formats of looking at cable bodies, right? Because you can either analyze a certain joint, or you can analyze a certain portion of the body, very similar to trusses. So both of these are almost identical to how they would have been used in trusses. So in that sense, it's fairly familiar, but the only thing that's actually different is the fact that all of the forces in the sections you're cutting are tensile forces. So other than that, it's fairly familiar, I think. As a reminder, you have your quiz in about a week. Some have like a week and 2 days, I think. And cohort B has a week and 2 days to do that. But here are my office hours, so please, please, please prepare. Come to the office hours. I'm going to try to come up with an additional resource to have just so I can see how it works. But yeah, so just to put it in perspective, I'm starting to prepare for the review session for your second exam, which means you guys should probably start thinking about studying for the second exam. So the earlier you start, the better you'll do, guaranteed. So probably consider starting to work. Other than that, that's all I have. The next video should be up after you do the lessons. So other than that, have a great rest of your week.